The histogram shows the distribution of stops for red traffic lights a commuter must pass through on her way to work. Use the histogram to find the mean, variance, standard deviation, and expected value of the probability distribution. To the right, you'll see the graph that we're going to be using for this particular problem. The first thing that you need to understand is that this is a probability distribution, and that these values at the top of each bar in the histogram represents the probability of occurrence for each one of the given categories in this particular problem. This would be the number of traffic or red traffic lights in the morning commute. And we'll go ahead and create a quick table that represents the probability. So the probability of no traffic lights will be equal to 0.06. The probability of one traffic light will be equal to 0.23. The probability of two traffic lights will be equal to 0.34, and so on. So the first thing that we're going to calculate will be the mean. Now the mean of a probability distribution is simply where you take each value, each x sub I, and multiply it by its corresponding probability. And this will be using the following formula. The mean, or mu, will be equal to, now you'll notice the formula is given as x sub 1 times p of x sub 1 plus x sub 2 times p of x sub 2 all the way down to plus x sub 6 times p of x sub 6. Remember that there are exactly 6 elements that we're going to be dealing with here. 1, 2, 3, 4, 5, and 6. So what we're going to do is go ahead and set up the formula. Mu will be equal to x sub 1, and we'll start with x sub 1 coming from this right here. So we'll have x sub 1, which will be 0, because that is our initial value in the distribution, times its probability of occurring, which is going to be 0.06. And then we'll add to that x sub 2, which will come from this one, which will be 1, times 0.23. And then we will continue and use each one of these values to create a multiplication. So entering this string into your calculator, we find that the mean is equal to 2.34. In addition, we'll see that when we just go to determine what the expected value is, it will be the same thing. In a probability distribution, the mean will be equal to the expected value. So not only do I have the mean, but I also have the expected value. But we'll discuss that as we get to that in the course of answering or completing the question. The next thing that we talk about will be the variance, and there is a special formula that we must use for the variance. This formula is as follows. Starting with part B, where we discuss the variance, we'll be looking at sigma squared, and this is a lowercase Greek letter sigma, and that means, and this whole thing means variance. And that's going to be equal to sigma. This is the uppercase Greek letter sigma, which means sum of. And that will be the sum of the difference of each x value in the mean squared times the probability of each occurrence. Now, the easiest way to do this is to use a table. So we will create a table which will show us what our calculations are and make things a little easier in the grand scheme of things. The first column in your table will be x, and that's going to be each one of the number of red traffic lights. So we'll start with 0, 1, 2, 3, 4, and 5 will be the end for this. Then we're going to have a column that will be x minus the mean, And when we do that, this one is going to simply be 0 minus the mean, which is 2.34. Then the next column will be that value, x minus mu, and then we will square that value. So this will be negative 2.34 quantity squared, and that will be equal to 5.4756. Notice that I have not rounded this off, and I will carry this out to at least 4 decimal places to minimize the possibility of round off error. Then the next column will be our p of x. I'm just going to write this here. And remember that the p of x for this particular entry was 0.06. And the reason that I write this down is because we're going to use this value and multiply it by x minus mu quantity squared. So I will multiply these two values, and that's going to give me the heading and the next column, which is going to be the x minus mu value squared, and I'm going to multiply that by p of x, which means that we have 5.4756, and we're going to multiply that by 0.06, and that will be equal to 0.328536. Like I said, I'm going to try to carry this out as far as possible to minimize round off error. So then we'll start with the next row, and this will be 1 minus the mean. Remember that the mean is 2.34. And this will be equal to a negative 1.34. Once again, we'll take the negative 1.34, which is the x minus mu, and we will square that, and that will be equal to 1.7956. And we will multiply that by the probability of x for this one, which will be 0.23. And that value will be 0.412988, and then we will complete the next four rows. Once we've gone through this entire table and filled in every component, we are going to sum the final column, which means that we want to go ahead and total this column right here. And that will be equal to 1.8644. And that is going to be the variance. Now, once we've calculated the variance, the next part would be to find the standard deviation. In this case, the standard deviation is simply the square root of the variance, and that will be equal to the square root of 1.8644. And that will be equal to 1.365430,335. And I'm sure there's more. It continues on. Now remember that you're going to need to round these values to what's indicated in the directions.